Okay, this section is about the inverse of a matrix. If we let matrix A be the matrix that we see here and matrix I be the matrix that we see here, I want you to remember that we just talked about matrix multiplication, and I want to look at what happens when we multiply A times I and I times A. So remember, matrix multiplication is rows from the first matrix multiplied by columns in the second. So if we take the first row of the first matrix and think about that -2, 3 being written out front, to get the first entry here, -2 times 1 is -2, and 3 times 0 is 0, and -2 plus 0 is -2. Moving on to the second entry, we're still taking that same row, -2, 3, but now we're multiplying by the second column. So -2 times 0 is 0, and 3 times 1 is 3. Okay, we're done with the first row, so we're going to go ahead and grab the second row of matrix A, -6, -8, and think of that -6, -8 as being written out front. -6 times 1, -6, and then we'd be adding that to 0 there. Similarly, if that -6, 8 were out front, -6 times 0 is 0, and -8 times 1 would yield -8. Go ahead and hit pause on the video right now and see if you can multiply I times A. Hopefully, when you multiplied I times A, you got -2, 3, -6, -8, just like this. So what I want you to notice is both of these matrices are the same, and in fact, both of them are actually equal to the A that we started with. So it turns out that A times I is in fact just A, and I times A is also just A as well. For that reason, because when we multiply by I, the identity doesn't change. See, we start with A, we multiply by I, we still have A. Or if we have I and we multiply by A, we still have A. This I that you see right here is what we call the identity matrix, and this one happens to be the 2 by 2 identity matrix. What you should notice about the identity matrix is that there are 1s along that main diagonal from left to right and 0s everywhere else. If we wanted to look then at the larger 3 by 3 identity, we would want to see the same thing just in a 3 by 3 matrix. So we'd want to see 1s along the main diagonal from left to right and then 0s everywhere else, just like this. All right, when we start to talk about the inverse then of a square matrix A, which by the way will be denoted A inverse, that is the matrix that when multiplied by A yields I. So this means that if we take A inverse times A, we should get the identity matrix. And if we do A times A inverse, we should also just get I as well. To find the inverse, we augment the matrix A with the identity matrix, and then we use those row operations that we've been discussing until A becomes the identity, and then the actual inverse will be sitting on the other side. Let's go ahead and take a look at an example to see what I mean there. So we're going to start by taking the original matrix, -2, 3, -6, -8, and we're going to augment that with the identity matrix. And because this is a 2 by 2, we're just using that little 2 by 2 matrix that had 1s along the diagonal and 0s everywhere else. Now, when we're doing our row operations, the goal is to make this look like the identity. And doing that is very similar to that Gaussian elimination process where we worked on getting this matrix into reduced row echelon form. In fact, that's exactly what we'll do first. We'll go to reduced row echelon. So remember, reduced row echelon, our roadmap was to get a 1 in the first position, then a 0 below, then we'll have a 1 here. At that point, it will almost be the identity. We'll just have to do one more step to make this 0 as well. So for now, just focusing on reduced row echelon, the first step is getting a 1 in the first position. So -2 times what would give you 1? Well, -1/2. So I'm going to start with -1/2 times row 1. So if we do -2 times -1/2, that's +1. 3 times -1/2, -3/2. And we're going to keep multiplying. 1 times -1/2, -1/2, and 0 times -1/2 is 0. After you have a 1 in the first position, the next step is to focus on the 0 below. Before we do that, though, let's just go ahead and copy the second row exactly as it is. -6, 8, 0, 1. So trying to make that -6 a 0, it would be nice if the number above it were a +6. So to make the number above it a +6, we're going to do 6 times row 1, and then we'll add that to row 2. When we do this, we don't actually want to change the first row. So I'm going to copy the first row exactly as it is so that I don't change that. Now, multiplying the top row by 6, let's just write down here what we get. 6 times 1 is 6. -3/2 times 6/1. That would be a -18/2, but -18 divided by 2 is -9. -1/2 times 6, -3, and finally 0 times 6 is 0. And now we're going to go ahead and add that new red row to the row below it. -6 plus 6, 0. -8 plus -9, -17. 0 plus -3, -3. 1 plus 0 is 1. Okay, so we're almost to reduced row echelon. If we wanted reduced row echelon, we just need to make this a 1. So think -17 times what is 1? Well, -1/17. So we're going to do -1/17 times that row 2 to go ahead and make that a 1. Again, the top row is not changing, so I'm going to copy row 1 exactly as it is. And now my new bottom row, multiplying by -1/17. 0 times -1/17, 0. -17 times -1/17, 1. -3 times -1/17, +3/17. And 1 times -1/17 is a -1/17. Finally, to finish, we just need to get this to look exactly like the identity, which means the last step is now to make that -3/2 a 0. And in order to do that, I want to look to the bottom number here below it, and it would be nice if instead of a 1, that were a 3/2. So I'm going to do 3/2 times that row 2, and then add that to row 1. The bottom row already looks like the identity on the left, so I'm going to copy that first. Now, multiplying row 2 by 3/2, let's write what we'd get up top here since we're going to go ahead and add it to that first row. 0 times 3/2 is 0. 1 times 3/2, 3/2. 3/17 times 3/2, just straight across, 9 on top, 34 on bottom. And -1/17 times 3/2, -3/34. Adding that now to the top row, 0 plus 1 is 1. 3/2 plus -3/2, the 0 we wanted. 9/34 plus -1/2, or 9/34 minus 1/2 If you want to use your calculator, just go ahead and do that. Just make sure you're changing it back to a fraction. We don't want decimals. So -4/17. And finally, -3/34 plus 0 would give a -3/34. So if we look at what we did there, we took the original matrix A and we augmented it with the identity matrix. Then we performed row operations until we ended up with the identity matrix here, which means our inverse is sitting over here. And because this was called matrix A, we'll call our answer A inverse. So here A inverse would be equal to -4/17, -3/34, 3/17, and -1/17. Looks like this. Okay, so for the next one, when they ask us to find the inverse of matrix B, we're going to start that out the same way. We're going to go ahead and start by taking the original matrix B exactly as it is, and then augmenting that with our identity matrix, which looks like this. Okay, now remember what you want to do. You want to perform row operations until this looks like the identity. And to get started, you're just looking for reduced row echelon. Remember again, the last step is just to place the 0 up here. So your roadmap again for reduced row echelon was 1 in the first position, which is already there. Then your next step is to focus on the 0 below. Then you'll get a 1 in this position, and then the very last step, 0 above. So this one is a lot easier than the one I just did. This would be a good point in the video to go ahead and hit pause again and try that one on your own. Okay, so hopefully you started by looking at that -2, and if you want that to be a 0, then you would want the number above to be a +2. So you should have done 2 times row 1 and added that to row 2. You weren't really changing the top row, so start by just copying the top row exactly as it is. Now, multiplying that top row by 2, I get 2, 4, 2, 0, and then I'm going to go ahead and add those 2 rows together. -2 plus 2, 0. -3 plus 4, 1. 0 plus 2, 2. 1 plus 0, 1. And that worked out really nice because not only did you get the 0 below, but you also got this 1 here as well. So if we want this to look like the identity, all we have left to do here is make this a 0 above. So in order to do that, it would be nice if instead of a 1, that were a -2. So you should have done -2 times row 2 and added that back to row 1. This time, it's the bottom row that's not actually changing. So the bottom row looks exactly the same, just like that. Now when I multiply that bottom row by a -2, I would get 0, -2, -4, -2. So those 4 numbers got multiplied by -2, but now we're adding them to row 1. So we're adding 1 plus 0 is 1, 2 plus -2, 0, 1 plus -4, -3, 0 plus -2, -2. And at this point, we now see the identity over here, which means this represents our inverse. This time, though, we started with matrix B. So for our answer, we would state that B inverse here is equal to -3, -2, 2, 1. Looks like this. Okay, so these were a little bit easier because they were 2 by 2s. They were just smaller, so to speak, than if we are to look at a 3 by 3. If we're doing a 3 by 3 though, it's going to be the same thing. We're just going to use that 3 by 3 identity. So we'll start by first copying the 3 by 3 matrix on this side, then we'll put the 3 by 3 identity here. Then we'll work towards reduced row echelon first after we have reduced row echelon, then we'll get the zeros that are above that we see up here in the identity. So again, your roadmap for the 3 by 3 is a 1 in the first position, then the zeros below. Then you got a 1 in the middle, then the 0 below, then a 1 in this position, and finally, to finish, to get to the identity, then you get those 2 zeros above, and the last step is to get a 0 here. So let's go ahead and take a look at those bigger 3 by 3 matrices next. So this first one, asking us to find the inverse of the 3 by 3 that we see here. We're going to start by copying the original matrix exactly as it is. 1, 3, -2, -1, -5, 6, and 2, 6, 3. I'm going to go ahead and augment that with the 3 by 3 identity that would have 1s along the diagonal and 0s everywhere else. Looks like this. Okay, so first step, work towards reduced row echelon, which means 1 in the first position. Notice that 1's already there. Now focus on the zeros below. So to get the 0 right below that, you could actually just add row 1 to row 2. You're not changing that top row, so 1, 3, -2, 1, 0, 0. And now adding row 1 and row 2, 1 plus -1, 0. 3 plus -5, -2. -2 plus 6, 4. 1 plus 0, 1. 0 plus 1, another 1. And 0 plus 0 is 0. Continuing, if we want a 0 in this position, because this is a 1, or sorry, because this is a 2, we want that 1 to be a -2. So now I'm going to do -2 times row 1, but now I'm adding that to the bottom row, row 3. So multiplying the whole top by a -2, I would get 1 times -2, -2. 3 times -2, -6. -2 times -2, 4. 1 times -2, -2. And then 0, 0. And we're going to go ahead now and add those two rows together to get 0, 0, 7, -2, 0, 1. Looks like this. Okay, so reduced row echelon again, 1 in the first position, 0's below. Next step was always to get that 1 in the middle. So to do that, we think -2 times what is 1? Well, -2 times -1/2. So we're going to do -1/2 times row 2. So my top row and my bottom row are not changing. We're just changing row 2, the middle row right now. So I'll start by just copying row 1 and copying row 3 exactly as they are. Looks like this. Now multiplying that middle row by a -1/2. 0 times -1/2, 0. -2 times -1/2, 1. 4 times -1/2, -2. And then 1 times -1/2, -1/2. Then another -1/2, and 0 there. Okay, so once you have the 1 in the middle, the next step would be the 0 below. I want you to notice that you already have that 0 below that. So next step is going to be to focus on making this this 7 a positive 1. So 7 times what would give you 1? Well, 1/7. So now we're going to go ahead and do 1/7 times row 3. Top row, not changing. Middle row, also not changing. Bottom row, multiplying everything by 1/7. 0, 0, 1, -2/7, 0, 1/7, like this. And I see a mistake. Okay, so all the way back here in the first step, that 3 should have been a -3. So let's see if we can fix things very, very carefully here. If that 3 was a -3, then when we added these two rows together, this 7 actually should have been a 1 right here, which would have made this also a 1. And now we don't even need this step that we just did because we already have the 1 in this position. So at that point, we were already in reduced row echelon. So from here, instead of worrying about making this a 1, this is already a 1. What we want to do instead is we want to focus on getting the zeros above that. And getting the zeros above that would require this 1 becoming the number 2. So to make that the number 2, we want to do 2 times row 3, and we're going to add that to row 1 to make this the 0. And then to make this the 0, we're also doing 2 times row 3, but we're now adding that to row 2. So the only row that we aren't changing is going to be that bottom row that looks just like this. Okay, multiplying row 3 by 2, 0, 0, 2, -4, 0, 2. When you add it to the top row, we're going to get the 0 here. So 0 plus 1, 1. 0 plus 3, 3. 2 plus -2, 0. -4 plus 3, or sorry, -4 plus 1, -3. 0 plus 0, 0. And 2 plus 0 is 2. Okay, adding that same new row to the middle row will also give a 0 here. So 0 plus 0, 0. This 0 plus 1, 1. 2 plus -2, 0. -4 plus -1/2. That would be a -4 1/2. But we don't want mixed numbers. We also do not want decimals. Just call it -9/2. 0 plus -1/2, -1/2, and 2 plus 0 is 2, like this. Okay, continuing. To finish, all we need to do is make this a 0. And in order to make this a 0, we're going to want this number below it to be a -3. So we're going to do -3 times row 2, and we're going to add that back to row 1. The bottom two rows are finished at this point. So you might want to go ahead and just copy the bottom two rows exactly as they are. Okay, now to get my 0 here, we said we were multiplying that middle row by a -3. So I would have 0, -3, 0. I'll just write that above here. And now when I do -9/2 times -3/1, that's going to be a 27 on top and a 2 on bottom. -1/2 times -3, +3/2, and 2 times -3 is -6. And we're going to go ahead and add those two rows together so that we see the identity here. 1, 0, 0. Okay, 27 over 2 minus 3. Let's just use the calculator here. Go ahead and change that to a fraction. 21 over 2. 3 halves plus 0, 3 halves. Negative 6 plus 2, negative 4. And because the name of this was A, right here, we would call this A inverse. And you can see how easy it is to make a mistake. Even I made a mistake. So we have to be really, really careful with our positives and negatives when we're running through these. And one little mistake will throw the answer off. I'm just glad we caught that one. This one, B here, if you were trying to find the inverse, you would want to start by copying the original exactly as it is. After you've done that, you're going to go ahead and augment that with the identity. That would look like this. Okay, so next step is to make this look like the identity in order to find the inverse. And you want to think about reduced row echelon first. So first step is getting a 1 in this position, then your zeros below. After that, get a 1 in the middle, 0 below, then make this a 1. After you've done that, you'll have reduced row echelon. Then focus on the zeros above. Last step, go ahead and get a 0 here. So again, this would be a good point in the video to go ahead and hit pause and try to do that on your own. All right, so to start, to make this number a 1, I would have done 1/2 times row 1. Multiplying the entire row 1 by a half, I get 1, 1/2, negative 1/2, 1/2, 0, 0. And in this step, I'm going to leave the other 2 rows alone. So I'll just copy those exactly as they are. Okay, once we have the 1 in the first position, now we're focusing on zeros below. So because this is a 6, it would be nice if this were a negative 6. So I'm doing negative 6 times row 1, and I'm going to add that to row 2. Similarly, because this is a 4, I would want that top number to be a negative 4. So I'm also going to do negative 4 times row 1 and add that to row 3. The only row I'm not actually changing is that top row itself. So I'm going to copy the top row exactly as it is, just like this. Now multiplying row 1 by negative 6. Let's just write up here what I get. I get a negative 6, a negative 3, a positive 3, a negative 3, 0, 0. And that's what I'm adding to the middle row to get 0, 1, 2, negative 3, 1, 0. We're also multiplying row 1 by a negative 4. So top row being multiplied by negative 4, I'm going to write down here what I get. Negative 4, negative 2, positive 2, negative 2, 0, 0. And we're combining that with row 3. I get 0, 0, negative 1, negative 2, 0, positive 1. And that worked out nicely. Not only did it give us the zeros below, but it did put a 1 in the middle. That would have been our next step. And it even put a 0 here, the next step after that. So now we want to focus on making this a 0. So easiest way to make that a 0 would just be to do a negative row 3. So row 1 and row 2 remain the same. we're just doing the opposite of the bottom row. So changing the signs, I get 0, 0, 1, 2, 0, negative 1. Okay, now we want to focus on the zeros above. So making this number here a 0, because that's a 2, I want a negative 2 below it. So I'm doing a negative 2 times row 3, and that's the one getting added to row 2. And getting the 0 up here, that's a negative 1/2. I want the bottom number to be a positive 1/2. So I'm also doing 1/2 times row 3, added back to row 1. The only row that didn't change was the actual bottom row, which stayed the same, like this. All right, now multiplying the bottom row by a negative 2. I get 0, 0, negative 2, negative 4, 0, positive 2. And that's what gets added to the middle row to give 0, 1, 0, negative 7, 1, 2. And finally, 1/2 times the bottom row. 0, 0, 1/2. Let's write it up here. 2 times 1/2 is 1. 0 times 1/2, 0. And negative 1 times 1/2, negative 1/2. And we're going to go ahead now and add those two together. 0 plus 1 is 1. 0 plus 1/2, 1/2. 1/2 plus negative 1/2, 0. 1 plus a half is 1 and 1/2, but again, write it as 3 over 2. Then I'll have a 0 and then a negative 1/2. Last step is to get the 0 right here. So because this is a 1/2, I want the number in the middle there to actually be a negative 1/2, the one below it. So we're doing a negative 1/2 times row 2, and that's getting added to row 1 to make this a 0. All right, bottom row is done, and middle row is done. So we're going to copy those two rows exactly as they are so we don't accidentally change them. Okay, now multiplying row 2 by a negative 1/2, I would get 0, negative 1/2, 0. Negative 7 over 2 times negative 1/2, positive 7 over 2. 1 times negative 1/2, negative 1/2. 2 times negative 1/2, negative 1. And we're going to finally add that to the top row to get 1, the 0 we were looking for, 0. Now 7 halves plus 3 halves is 10 halves, but 10 divided by 2 is just 5. Negative 1/2 plus 0, negative 1/2. Negative 1 plus negative 1/2 is negative 1 and 1/2, which is written as negative 3 over 2, like this. And because this was matrix B, once you have the identity here, this is called B inverse. Okay, so let's talk next about how to find the inverse using our calculators. So let's actually check here. I caught the one mistake that I made when I was doing that one. Let's see if I made another mistake as well. So if I wanted to check that, in fact, let's cover up that mistake there. What we're going to do first is we're going to find our matrix button on the calculator. So mine's right here in blue. So to get to that, I need to hit second and then matrix. And right now, I've got other things in there. You probably don't have anything, but what you're going to do is you're going to scroll over to edit like this. So edit is highlighted and A is highlighted. And you're going to go ahead and hit enter at that point. Matrix A is into 2 by 2. Matrix A, the original problem up here, is a 3 by 3 matrix. So I did 3 enter to change the size of that matrix. Now I'm going to go ahead and input the original matrix. You can use the arrow keys or you can hit enter after each entry. I think it's quicker to hit enter. So I'll just do 1, enter, 3, enter. -2, enter. And I'm just going to keep going. -1, -5, 6, 2, 6, -3. All right, before I do anything, I like to make sure that all my numbers are exactly the same here and here. And that looks good. So I want to go back to the home screen. So to go back to the home screen, we're just going to quit out of this here. And then I want to tell my calculator now to compute A inverse. So to grab matrix A that you just stored, you have to hit second matrix again. And see how A is highlighted and A is now changed to a 3 by 3? That's the matrix we just stored. So I'm going to go ahead and hit enter, and it brings A into the home screen. And if I want it to find the inverse of A, I'm just going to do A inverse like this. Okay. And again, I'm not interested in decimals, so hit your math key, and that will change the entire matrix into fractions. And let's see, 21 over 2, 3 halves, -4, -9 over 2, -1/2, 2, -2, 0, 1. Looks good. At this point, it would be good for you to hit pause and go ahead and check my work down here to see if I made any mistakes in this one. Okay, looks like that one worked out okay. This next problem doesn't want us to do anything by hand. It just says to use a calculator now to find the inverse of this matrix. And I would never ask you to do a 4 by 4 matrix by hand. That would always just be done on your calculator. So if we're trying to find the inverse of this matrix on our calculator, we're gonna hit the matrix key again. We're gonna edit matrix A. This time though, we have a 4 by 4 matrix. And I'll just go ahead and input that 4 by 4 matrix. Okay, once we've done that, again, I'm just double checking all my entries there. Everything looks good to me. So this and this are exactly the same. Now, quit again, back to your home screen, and you're gonna grab matrix A. So second matrix, here's matrix A, now a 4 by 4 matrix, and we want it to find the inverse, like this. And you can see the answer sitting right there. So for the answer to this one, you would just copy from your calculator 0, 1, -1, 0. Set that up here. -13, -1, 2, 3. -6, 0, 1, 1. -4, 0, 0, -1. And there's not really work to show. If any work, you might want to just write that the command you gave your calculator was A inverse, and it would look like this. So that's how we do inverses by hand, and then this is how we find inverses using our calculator. We want to talk next about how to solve a system using an inverse then. So solving systems using matrices, if you were looking at this simple equation, AX equals B, obviously if A and B were numbers instead of matrices, if I asked you to solve for X, you all would tell me to divide by A, and X would be B over A. The problem though is that A and B aren't numbers. A and B are matrices. And we talked about how to multiply matrices, how to add and subtract matrices, but we never talked about dividing two matrices. So for this reason, this doesn't work when A and B are matrices. Instead, if we were trying to get X alone, we want to remember that when we multiply by the inverse, we get the identity. So in this equation, if I multiply A inverse times A times X, so all I did is I took the left side of this equation, and on the left, I did matrix multiplication, multiplying by A inverse. And because it's an equation, I need to do the same thing to the right-hand side of that equation. So I want to multiply on the left of that B by A inverse as well, like this. At the beginning of this section, we said that the definition of an inverse was if you multiply A inverse times A, you get the identity. So A inverse times A is in fact I. So that will just say I times X is A inverse B. And I times X, or I times the identity times X, is just X. Remember, it was called the identity because it doesn't change the identity of what you multiply by. And finally here, we'll see that X is in fact equal to A inverse times B, like this. So if I look at this little 2x2 system that we see here, and I want to solve it using matrices, let's see if we can just set up that system using matrices. So if I start with the coefficient matrix 2, 3, 1, 2, like this, and I multiply that actually by the variable matrix, which would just have X and Y in it, and then set it equal to the constant matrix, that would be that skinny matrix on the other side. I want you to notice this matrix multiplication, rows of the first by columns of the second, would yield that same system. See, if we took the first row, 2, 3, and rewrote the 2, 3 out front and multiply, it would say 2x plus 3y, the first equation, and then it would be equal to 5, the first entry here. And if I took this row, 1, 2, that would be x plus 2y is 4. So the coefficient matrix is matrix A. This matrix is what we're referring to as our variable X. And the constant matrix from the other side is matrix B. And notice it has that form that we just talked about here, AX equals B. And we just discussed that if AX equals B and we're trying to find X because we're trying to solve for X and Y, then X will in fact just be equal to A inverse times B. And you can just use your calculator to compute A inverse times B. So in order to do that on our calculator, we want to start by hitting our matrix button, and we want to edit matrix A first. And for matrix A, I'm just going to put in that 2x2 coefficient matrix that we saw here. 2, 3, 1, 2. Okay, I also need to put in matrix B as well. So I'm going to hit second matrix again, go over to edit first, then I'm going to drop down to B. And B, if you look at the size of B, B has 2 rows and 1 columns. My calculator already has a 2x1 in it. So if yours doesn't, you'll have to enter the size 2x1, 2 rows, 1 column. So remember, it's always rows first, then columns. And then you're going to put in that matrix B, 5, 4, like this. So now I have A stored in my calculator. I also have B stored in my calculator. Now I'm just going to go into the home screen, and I'll have my calculator do the whole thing, just typing in A inverse times B. So if I quit out of this, back to the home screen, hit second matrix, grab matrix A, take its inverse, hit second matrix again, and grab matrix B like that. So I haven't hit enter yet at all. So again, grab matrix A, hit the inverse key, which is that -1 there. Grab matrix B. Now hit enter, and it's going to compute the inverse first and multiply by B to give you this skinny matrix, negative 2, 3, that looks like this. And what I want you to notice about that is that X stored X in the first row and Y in the second row. So if we were trying to solve this little 2 by 2 system, we now know X is negative 2 and Y is 3. So I would write my answer as the point, negative 2, comma, 3. Looks like this. I want to look at the same problem again and show you that if we were to have just used the elimination method instead of using the matrices, we would have got the same exact solution. So remember your elimination method. Because this is a 2x, let's make this a negative 2x. So I'm going to copy the first equation, 2x plus 3y equals 5. Exactly as it is. And now I'm going to multiply the whole bottom by negative 2 to get negative 2x minus 4y is equal to negative 8. Then when I add those together, the x's eliminate and we get negative y equals negative 3. Dividing by negative 1, we find y is 3. To find x, we want to grab either of these equations. I like the bottom one better. And I'm just going to grab that bottom equation and now replace y with 3. X plus 2 times 3 is 4, or x plus 6 equals 4. When I subtract 6, x is in fact negative 2. So if I write my answer as a point, x first, then y, same solution, negative 2, comma 3 that we saw up here. So A inverse times B and using the elimination method both produce the same solutions. This one would take a really long time to do using elimination method, right? Because we're dealing with 3 equations there. But this would actually be fairly easy to work out A inverse times B. So to show your work when you're asked to solve one of these, the directions would tell you to solve using inverse matrix methods. So when it tells you to solve using inverse matrix methods, they're talking about use your calculator to do A inverse times B. So for your work, what you would want to do is tell me what you're putting into your calculator. So you're going to tell me that matrix A is the coefficient matrix. Using that system, the coefficient matrix would be 1, 2, negative 1, 2, 3, negative 1, 3, 6, negative 2. And then you're also going to tell me that matrix B is the constant matrix, the skinny matrix 5, 8, 14 from the other side. Now I'm just going to grab my calculator and go ahead and store matrix A and matrix B. So edit matrix A, my 3 by 3 matrix. So I'm just entering the coefficient matrix we just discussed. And then I'm also going to enter matrix B. So edit, go down to B. And B has 3 rows now and 1 column. So 3 by 1. And I'm going to put in 5, 8, 14, like this. Okay, now I want to go to the home screen, second, quit, and I want to tell my calculator to do A inverse times B. So we're going to grab second matrix, matrix A, hit the inverse button, and I don't want to compute the inverse, I want to compute A inverse times B. So don't hit enter now, instead, second matrix, grab matrix B. And now my calculator is going to do the whole A inverse B, and it tells me that A inverse B is in fact 2, 1, negative 1. So I'm just going to go ahead and write that as the point 2, comma, 1, comma, negative 1. Okay, so triple ordered pair, X, comma, Y, comma, Z. We could also do this using a 4x4 matrix. So when you look at a 4x4 matrix, they typically use W, X, Y, and Z. So if you look at this first one's missing the Z. So when you go to start listing matrix A, the coefficient matrix, the coefficient on W is 1, coefficient on X, -1, coefficient on Y, 2, but because Z is missing, fill in a 0 there. Okay, continuing. Row 2, 2, -1, 6, 2. Row 3, 3, -2, 9, 4. This has a W and an X and a Z, but it's missing the Y. So this would be 1, -2. The Y column would have a 0 then, and Z is -1. I'm also going to state what B is before I punch it into my calculator. 5, 16, 28, and 2. Okay, now on my calculator, I'll go ahead and enter matrix A and matrix B. So second matrix, editing matrix A, we now have a 4x4 matrix. 1, -1, 2, 0, 2, -1, 6, 2, 3, -2, 9, 4, and 1, -2, 0, -1, like this. And again, just a quick check that I didn't make any mistakes when I put that in. Looks good. I'm also going to do matrix B there, 4x1, 5, 4x1, 4x1, there we go, 5, 16, 28, and 2. Looks like this. So in my home screen, so quit out of this, I'm going to grab matrix A, second A. I'm going to take its inverse, and then I'm also going to go grab matrix B. And calculator gives us a solution there. When you have 4, just instead of a triple ordered pair, it's a quadruple ordered pair. So always in that order, 1, comma, -2, comma, 1, comma, 3. And my answer would look like this. Okay, so that is how you solve systems, again, using inverse matrix methods. So when it's asking you to use inverse matrix methods to show your work, A, the coefficient matrix, write that down. B is the constant matrix, write that down. Then tell me what you're punching into your calculator. The command you give your calculator is A inverse B, and then you can go ahead and get the solution straight from your calculator. So that's a quick way to use your calculator to solve systems.